Questions. What is a service? Service is a logical grouping of sessions performing similar kind of work. They enable you to group database workloads and route work to the optimal instances that are assigned to offer the service. It is recommended that all the users who connect using the service have the same service level requirements. We can use services to manage workloads or a group of applications. For example, all online users can use one service, whereas batch users can use another service, and reporting can use another service. Benefits of services. Services make the work manageable, measurable, tunable, and recoverable. Services provide an abstraction layer and permits clients and middle tiers to access required data from the database independent of where the instance reside. Dynamic. As the load increases and reduces, the number of instances supporting a service can be increased or decreased accordingly. High availability. In case an instance crashes, the service is supported by it fail over to another surviving node. Tuning and monitoring. Tracing can be enabled for all sessions who connect using the service. This can be used to identify the culprit SQL statements issued by the user connected via service. The performance statistics are collected and aggregated via service. This can be used to find out the performance of all sessions belonging to a service. Two performance thresholds can be specified for a service: service elapsed time, service CPU time. The AWR monitors the service time and CPU time and publishes alerts when the performance exceeds the thresholds. In response to these alerts, you can change the priority of a job, stop overloaded process, or relocate, expand, shrink, start or stop a service. Resource management. We can bind resource consumer groups to service. The users who connect using a service will get the resource as per the allocation specified for respective consumer group in the active resource plan. For example, if OLTP and batch services are defined to run on the same instance, and a requirement is as follows: during runtime, OLTP users should get more resources, whereas batch users should get less resources. Okay. Right. During night time, batch users should get more resources, whereas OLTP users should get less resources. We can have two consumer groups, OLTP group and OLTP batch group batch, so that all users who connect using OLTP service are assigned OLTP group, and all users who connect using batch service are assigned batch group. We can have two resource plan: day plan, in which OLTP group is given more resources and batch group is given less resources; night plan, in which batch group is given more resources and OLTP group is given less resources. Okay, using transparent application failure. When a node crashes, all the services running on the instance hosted by that node will fail over to another node. From now onwards, the users who try to connect using a failover service will try connect to the instance supporting that service. But what happens to the session who are already connected using that session service at the time of the crash? This is defined by the TAF policy, which can be defined for the service. We can have three types of TAF policies: basic, pre-connect, and none. Basic. In this approach, the application connects to the backup node only after the primary connection fails. This approach has low overhead, but the end user experiences a delay while the new connection is established. Pre-connect. In this approach, the application simultaneously connects to both the primary and backup node. This offers faster failover because a pre-spawned connection is already in use, but the extra connection adds everyday overhead by duplicating connection. We can also specify failover type for service, that is, what kind of activity going on in the connector session will be resumed after the failover. It can be select or session. Select failover. With select failover, Oracle then keeps track of all select statements issued during the transaction, tracking how many rows have been fetched back to the client for each cursor associated with the select statement. If the connection to the instance is lost, Oracle net establishes a connection to another RAC node and re-execute the select statement, repositioning the cursor so that the client can continue fetching rows as if nothing has happened. The select failover approach is best for data warehouse systems that perform complex and time-consuming transactions. Session failover. When the connection to an instance is lost, session failover results only in the establishment of new connection to another Oracle node. Any work in progress is lost. Session failover is ideal for online transaction processing systems where transactions are small. The following types of transaction do not automatically failover must be restarted by TAF. Transaction statements. Transactions involving insert, update, and delete statements are not supported by TAF. Transactions using temporary segments in the temp table space are and global tables do not fail. Okay. Right. Connection load balancing. If we have multiple instances supporting a service, we can spread user connections across all those instances. For each service, you can define the method that you want the listener to use for load balancing by setting connection load balancing CLB goal underscore goal. It has two values, CLB goal long and CLB goal short. Okay. What are the dictionary views? DBA underscore services, DBA underscore RAC group mappings, DBA thresholds, DBA scheduler job classes, DNS names. Server side, local listener, remote listener, connect data, special entries, pre-connect, resource profiles, start dependency. Okay. Workload management involves failover. If connection to an instance fails, client should automatically connect to another instance. Load balancing, workload should spread across various instances to obtain maximum performance and throughput. So workload management involves failover and load balancing. Failover can be connect time failover and runtime failover. For a connect time failover happens while making an initial connection. Runtime connection failover happens after connection has been established or transparent application failover. Failover method can be done basic pre-connect, which is part of the runtime failover. Failover type, session select. Load balancing can be connect time load balancing and runtime load balancing. Connect time load balancing on client side and server side. Runtime load balancing. To configure failover load balancing, DNS Aura should contain multiple listener addresses to connect to multiple instances. Multiple listener addresses within a description. User is trying to connect to a service which is supported by multiple instances. Okay. Load balancing. Load balancing in RAC implies distributing the workload over multiple instances, accessing the same physical database. Two kinds of load balancing: connect time load balancing and runtime load balancing. Right. Connect time load balancing. This enables users to connect to one of the instances supporting the service. The connection stays with the same instance until the user disconnects or the session is killed. It can be configured on the client side or server side. Connect and load balancing on the client side. When a user session attempts to connect to the database, Oracle will choose an address specifying the DNS names .ora to connect to a random in a random order than the sequential order. This has the effect of clients connecting to addresses which are picked up at a random and no one address is overloaded. Its configuration is quite simple. You must need to set the parameter load balance is equal to on in the client definition. Load balancing parameter is set to on by definition. When this parameter is set to on, Oracle Net Services produces a list of addresses in a random sequence, balancing the load on several listeners. When it is set to off, addresses are tried out sequentially until one succeeds. When using scan in the connection definition, Oracle database randomly connects to one of the available scan listeners in a round-robin fashion and balances the connection on the 3 scan listeners. Okay. Limitation of connect and load balancing. The connection stays with the same instance for the life of a session. If connection lasts a long time, it might be possible that the load of the current instance increases and some other less loaded instance might be preferable. In that case, we would like the connection to switch to the other more appropriate instance. This can be achieved by using runtime load balancing. Connect and load balancing on server side. After the listener receives a connection request, it can forward the request to another instance based on connect and load balancing code. Okay, CLB underscore goal can be long or short. Used for application connections that had connected for long periods, such as third-party connection pool and SQL Forms application. In this case, listeners will load balance on number of sessions. Runtime load balancing code will not be used in this case. Short. Used for application connections that are short in duration. This should be used with connection pools integrated with load balancing advisory. In this case, listener uses load balancing advisory to make connection based on CPU utilization on the node. The listener has no idea the session has been assigned to an endpoint whose corresponding database server is already overloaded. Hence, the timeouts can occur if the node is heavily loaded and unable to respond quickly. Hence, to overcome this problem, server-side connect time load balancing needs to be configured. It is useful to spread initial connection load among all listeners in the cluster. Clients may then be redirected based on the server-side load balancing. In this case, listener routes incoming client connection according to policies and based on current service level provided by the database instance. The listener determines the connection distribution depending upon the profile statistics that are dynamically updated by pmon. The higher the load on the load, the more frequently pmon updates the load profile. Thus, connection may be switched depending upon changes in the cluster configuration, application workload, and overloaded nodes or hunks. The core of the server-side load balancing. So the services are registered with all the service listeners. Since pmon on each node sends load profile to all of the listeners with which the service is registered, all the listeners come to know about the okay. I get bored of reading this. Okay, go on, few more minutes. Go on, baby. Oh my god, 5 more pieces. Okay. Right. Okay. Runtime workload requests are automatically balanced across pool of connection. The connection allocation is based on current performance level provided by the database instance as indicated by the LPA. This provides load balancing at transaction level instead of load balancing at the initial connection. The listener directs connection requests to the best instance currently providing the service by using load balancing advisory. Is for workload across RAC instances, monitors workload activity for service across all instances in the class, analyzes the service levels for each instance based on defined metric goals, goal service time, goal throughput, publishes fan events recommending amount of work to be sent to each instance and data quality flag, default is off, directs work to where the services are executing well and resources are available, adjust distribution for different power nodes, different priority and shape and workload changing. Okay, how to configure server-side load balancing? Set parameter local listener and remote listener. Set CLB underscore goal is equal to short for the service. Set RTLB underscore goal for the service. Set parameter local listener and remote listener. Local listener parameter should be set to the name of the listener defined in the same node. Remote listener should be set to the name of the listener running on the other nodes, which would in this case be scan listener. When we start the 3 instances, the corresponding pmon process get dynamically registered with all the listeners and start feeding listeners with the load profile information. Now all the listeners come to know about the load profile of all the instances, hence the connection is forwarded to the listener of the least loaded node. When scan is used, remote listener parameter should be set to scan name on all the nodes. Right. So the pmon process of each instance registers the database with the default listener. CLB underscore goal short execute DBMS modify service to set this parameter. Set RTLB goal for the service. A request for connection is serviced by selecting connection based on the service goal as defined by the LBA advisory. The service goal determines whether the connection provides best service quality, that is how efficiently single transaction completes, or best throughput, that is how efficient entire job or online inquiry is complete. For RTLB, we can define service level goals which will be used only if CLB underscore goal short. Default setting, you are not taking advantage of this feature throughput. The work requests are directed based on throughput. Throughput should be used when the work in a service completes at a homogeneous rate. An example is a trading system where work requests are similar lengths. Attempts to direct work requests according to throughput. The load balancing advisory analyzes service level for each instance based on the service time and based on the rate the work is completed in the service plus available bandwidth in the service. For example, for the use of throughput is for workloads such as batch process, trading system, etc. Okay, load balancing can be connect time, load balancing, and runtime. And connect time load, this enables user to connect one of the instances supporting the service. The connection stays with the same instance until the user disconnects or the session is killed. It can be configured on client side or server side. Connect time load balancing on client side. When a user session attempts to connect to the database, Oracle NAT chooses an address specified in the TNS names to connect to in a random order rather than the sequential order. The parameter load balancer should be set to on. Limitation of connection load balancing on client side. The listener has no idea if the session has been assigned to a database. Corresponding database server is already overloaded. Okay. Connect time load balancing service. After listener receives the connection request, it can forward the request to another instance based on the connect time load balancing goal. Goal can be long or short. The listener Will load balance number of session runtime load balance short. Okay. Workload management, failover, load balance. I think we've already done this. Yeah. That's all for the notes that is related to service. Thank you for listening.